Join us on a journey with Helix, where innovation meets efficiency.
What I'm going to do today is go through a demonstration of Helix Ops and talk through how this could look for you. What we have here is an example of Helix Ops. It's a typical example that we have from a lot of our customers where they're perhaps operating anywhere from 1 to 10 spacecraft with their constellation. The Helix Ops as well can also go up to 100 plus spacecraft, but this is a more typical example from a lot of what our customers go through. In this case, our customer here, they've got their satellite operator and they've set up several spacecraft to do some automated plans and tasking over a weekend. They've come back on Monday morning and they want to get an idea of how their spacecraft are doing and what needs to be addressed. Has there been any warnings? Have there been any errors that they need to look into? This gives them a good view of that. Everything you see here is fully customizable, so this doesn't have to stay the same. It can be fully tweaked to match whatever needs you have for your mission. In the center here, we have a map view representing where your current spacecraft are in orbit, as well as their current state of health. Any of these circles represent a spacecraft, and green means that everything over the weekend has gone successfully. And everything that's in amber or red means that there's either been a warning or an error that you might want to look at. A warning could be anything from a low voltage, or a more critical warning or error could be something such as low power, where you might want to have your satellite operator repoint the satellite to recharge the battery. What we also have on this map is these diamond shapes, which represent the ground station network. You can also see on the left-hand side a full list of your contacts that are scheduled. You can see the ones that are going to happen imminently, the ones that are scheduled to happen at a later time, and the ones that have just completed it as well. We also have the next acquisition of signal and loss of signal of that spacecraft, as well as the ground station that you're going to make contact with. By selecting the spacecraft, you can see the orbital path of it, and you get more information about when you're next going to make contact. By selecting the planning tab like so, we can start to import new contacts and make sure that we are happy with all of the procedures assigned to them. We have a nice view here to show the satellite operator what their day is going to look like and when their spacecraft are going to make contact with the different ground station networks. We can also see which ones have got procedures assigned to them and which ones don't. And we have the ability to add in new contacts as well by selecting the Import Contacts button. Now we can either create these contacts manually or we can import them through a CSV file. By selecting this, we can import our new contacts, and you can see here that it's pulled them in without any procedures assigned. Your satellite operators will have the option to either automatically have procedures assigned to these or to assign them manually as needed. By selecting one of the scheduled contacts, we can now assign a procedure to them. If we select the Schedule Contacts button like so, you can see here that we have a number of pre-made procedures available with Ops that you can take advantage of. These will be mission dependent, and you have the option of creating your own procedures from scratch, but these ones would just give you a starting point to get you started in Ops. We can see here that some of them are active and ready to be used, while some of them are still in a draft state. You can also get information about when they were last updated, the number of commands within them, and a quick preview of what these automations look like. By selecting this procedure and assigning it to a contact, we can get a more detailed view of what this procedure will do. In this case here, we are going to downlink payload data, and we can start off by having these chunks of automation. This first chunk is a flight software automation, and you can see here that we're going to get the number of rows of our storage channel. We're going to get the length of our storage channel as well. We're going to get the data from our storage channel, and once we've received that data, we're going to wipe the storage channel as well, assuming that in this case the storage is perhaps not storing the data in a circular pattern. We also have additional automation here for the ground automation. We can decode the event logs and ingest them inside of Ops. And this allows you to have quite a powerful combination of flight software automation as well as ground software automation as well. Doing this means that you can start processing some data from your spacecraft, then ingest that data, and then based on the data you've received and ingested, you can do some additional automation as needed. As you'll see at the bottom right-hand corner here, we also get alerts for the users. So our satellite operators will be alerted when a new contact is underway. They'll also receive alerts if there was perhaps a warning or a critical issue that you might want to be looking at for one of your spacecraft. By selecting this View Contact button, we can see how our spacecraft is currently doing and as it's running through the procedure. You can see here that it's automatically running through each of the individual commands, and each of the telecommands is being ticked off as it is completed. You can also see the ones that are still in progress as well. Now, the satellite operator at this stage will have the option to stop or pause the procedure, and this would then allow them to do some manual commanding as well. They could then come back at a later stage and start back up again from where they left off, or restart it from scratch as needed. In addition to doing planning and operating, you also have the option of visual displays through dashboards. These visual displays will give your satellite operators a good view into the data that you're receiving and whether it is currently within the bounds and parameters that you would like it to be within. You can see here that we've got our batteries temperature and our solar panel temperature, and the red and amber lines across the charts here represent the boundaries for what we would expect the values to stay within. If these arrows were to go outside of this, then you would start to receive warnings and errors. And this also gives your satellite operators a good view on how far out of bounds these parameters are currently sitting. You can also get views such as the battery's current state of charge, but all of what you see here is fully customizable. We can create far more complicated and complex charts than this, but it's a good example of something simple that is easy to ingest by satellite operators. It's also worth mentioning that this view doesn't have to be done on a single window. Most of our satellite operators will run from anywhere from 3 to 6 monitors all at once. And what you could do in this scenario here is have up to 6 monitors all showing you different views of your spacecraft. One could be used for automation, one could be used for operation, and one could be used for doing dashboards and displays. What we can now do is we can go back to our contacts window like so, and you can see here that we've now completed the procedure that we were running through. This now lets us move on to doing some manual commanding of our spacecraft. By selecting the Control tab on the left-hand side here, you get a view of all of your individual spacecraft and whether or not they're connected to a ground station network. By selecting BA1 here, we can get a deeper dive into what the flight software is and how it's represented inside of the system. We also get the option of controlling the spacecraft manually at this stage. It's worth mentioning at this stage that the way that we ingest flight software into Ops is by using our flight kit model. What we will do is we take all of the flight software and we break it down into what we call components. Components will encapsulate some aspect of what your flight software can do. This will be batteries, automation, logging, everything. And this also allows you to create a single component and instantiate it many times. If you had 4 batteries on your spacecraft, then you could create one component for batteries, and you could instantiate that 4 times, configuring each of the individual instances to match the use cases. If we were to take third-party flight software, we would create a model in XML, similar to how we would do it in FlightKit, and we would create a mission database, which is then ingested into Ops. This consistency with how flight software is represented in Ops allows you to do procedures and handle a wide range of flight software, having full agnostic support within Ops. What we can do now is we can expand out this power subsystem, and we can see the individual components within it. We've got ones for battery, power distribution, and solar panels here. By expanding out solar panels, you can also see that we have the individual component instances that I mentioned previously. We can expand this out further to get a view of the individual parameters that we might want to get and set data for, as well as any actions as well. Actions can be represented like this storage channel wipe at the bottom here, and we would have the option to invoke this, just wipe the storage. And the ones at the top here are all parameters where we can either get, set, or a mix of either. By getting the data like so, we can see that we've got an acknowledgement that the command has been received and that we have received the data. And this would happen if we get, set, or invoke an action. By doing this, you will get an acknowledgement or a NAC from the flight software, and this will then be represented so that your spacecraft, your satellite operator can see whether or not their commands have been executed correctly. This has been a good example of typical use cases of a lot of our customers, but everything you see here is fully customizable. The only other thing worth mentioning is that when it comes to third-party ground software, we're aware that there's plenty of opportunities of other companies creating amazing tasking software to handle and operate your spacecraft. We're not trying to compete with them. We're not trying to create a software that is going to be revolutionary in the way that it handles one particular thing. We're trying to go for breadth in our approach. And to do this, we have GroundKit, which is another one of our Helix products. GroundKit will allow you to ingest and create supports for other ground software as well. This can then give you a very powerful tool where Ops is at the center of all of your ground software, controlling everything as you need it to.